wat ik onthoud, is dat 80% van de stedelingen permanent blootgesteld zijn aan te hoge waarden van PM10. En dan begrijp ik ook de figuur met de levensverwachting en met de concentratie van PM2,5. En dan zie je heel mooi als je gaat van de waarde 10 microgram naar 25, 30, dat je 3 jaar verliest. Dat is exact wat we hier in Antwerpen verliezen aan levensverwachting. De limieten die gebruikt worden door de Wereldgezondheidsorganisatie zijn puur vanuit gezondheid. De limieten, de waarden van de EU, van België, van alle landen, is een politieke consensus. Heel belangrijk, je moet gaan voor de limieten van de Wereldgezondheidsorganisatie. Ik weet nu waarom dat diesel niet werkt. De benzinewagens worden getest. En die test die de benzinewagens krijgen, reflecteert heel goed hoe zij werken in het echte leven van een wagen. En dan heb je hele lage emissies. De testen die ontworpen zijn voor de diesels, geven perfecte uitkomsten in het laboratorium, maar het werkt niet in de real world. Iets dat we kennen, maar dat we nu heel mooi geïllustreerd zien. En wat mij opviel, die kleine stofdeeltjes, dat is niet mooi rond. Dat is een ongelooflijke amorfe massa. Er zitten bacteriën op, er zitten zware metalen op, daar zitten allerlei chemische componenten op, die dan nog onderling met elkaar in gevecht gaan. En komt nu alle fijnstof van het buitenland? Zoals we ons graag laten geloven, dat we hier niks kunnen aan doen. De helft komt vanuit het buitenland. En dat is ongeveer 10 microgram. En 10 microgram is ongeveer de grens van wat de gezondheid van ons aan kan. Dus als we tot daar zouden kunnen terugbergen, zitten we goed. Laat ons bezighouden met wat we hier lokaal kunnen veranderen. 10 Global Act Local. Dank u.
Ja, welkom allemaal. Het is niet de eerste keer dat ik hier sta, maar wel de eerste keer dat ik hier van voor mag staan. Ik ben Maarten Loopmans. Ik werk aan de KU Leuven als sociaal geograaf. Maar ik ben eigenlijk vooral ook, net als de meeste mensen hier in de zaal, denk ik, een bezorgde Antwerpenaar. En als sociaal geograaf werk ik ook vaak samen met fysische geografen. En ik had een tijdje geleden nog een gesprek met een collega van mij die gespecialiseerd is in klimatologie. En enorm intelligente persoon die ongelooflijk ingewikkelde klimaatmodellen maakt. En daar alles van af weet. Maar het enige wat ze niet begreep was waarom niemand haar dramatische voorspellingen over klimaatverandering toch ooit au serieus neemt in het beleid. En dat is een soort van verwondering of ergernis waar heel wat wetenschappers mee bezig zijn. Van, we weten van alles wat er kwaad kan voor ons als mensen, maar er wordt niks aan gedaan. En dat is ook een beetje de achtergrond van het onderzoeksprogramma waar we vanuit Europa mee gestart zijn. Dat SEFIRA heet. De doelstelling van het project is eigenlijk dat we uitzoeken op welke manier de Europese richtlijnen rond luchtkwaliteit al dan niet doorwerken op lokaal niveau. En we doen dat via een internationale samenwerking. 5 case studies verspreid over Europa, Lombardije in Italië, Vlaanderen, de regio rond Warschau, Londen en dan de Öresund-regio, Denemarken en Zweden. En we hebben die locaties gekozen, enerzijds omdat daar interessante collega's bezig zijn, en anderzijds ook vooral omdat dat hotspots zijn voor luchtkwaliteit. Zij het omdat ze daar zeer zwaar aan vervuiling blootgesteld zijn. Zij het omdat er interessante experimenten bezig zijn die doorwerking van die luchtkwaliteitsnormen, het verbeteren van de luchtkwaliteit op lokaal niveau aan te pakken. Vlaanderen geldt eigenlijk voor de twee. We hebben net al op de kaart gezien dat er een rode of een zwarte vlek zijn op het vlak van luchtkwaliteit. Maar zeker Antwerpen is ook een heel interessante case study met, omwille van wat we hier in de zaal zien, weer al een paar honderd burgers die hun avond vrijmaken om een aantal drooglezingen over luchtkwaliteit te volgen. Dit is waarschijnlijk de meest geëngageerde plek in Europa rond luchtkwaliteit en dat heeft voor een groot stuk met te maken met de mobilisatie van de actiegroepen rondom. Dus bewustzijn en bewustwording rond luchtkwaliteit is hier heel sterk. We zijn ook heel blij dat we met SEFIRA, we hadden hier net een vergadering al 2 dagen lang met die internationale experts daar ook hebben kunnen bijdragen door onze samenwerking met de actiegroepen aan het verspreiden van kennis en informatie onder de Europese, in casu Antwerpse burgers. Dus er zijn een aantal van onze specialisten die heel graag hun uitleg kunnen doen over wat ze allemaal weten over luchtkwaliteit. De eerste spreker die we vandaag hebben is Martin Williams. Hij is een specialist luchtkwaliteit, professor aan King's College in Londen. En hij is eigenlijk een specialist in atmosferische wetenschap. Wat dat precies inhoudt, dat weet ik ook niet, maar hij gaat het er allemaal uitleggen. Martin.
Thank you, Martin. You'll excuse me, I will speak in English this evening. I will try and speak slowly. But if I do speed up, then maybe somebody can shout. Although the title says in English air quality standards, I'm not actually going to bore you with a whole list of numerical standards that are in existence in Europe. That would be far too boring for this time of night. So what I was going to do was just give you a very rough outline of what the kind of legal position is in terms of the different types of standard that there are and World Health Organization guidelines. And then go on to talk about some scientific aspects of the problem. And then I didn't think I'd come here and try and tell people in Antwerp what they should do to try and reduce the pollution. That would be far too arrogant and quite the wrong thing to do. So what I was going to end up with was just to give you some idea of some of the things you might think about when you're thinking about trying to reduce the pollution in Antwerp. So if I can get this to work, I'm going to try and run 2 computers here, one in English and one in Dutch. So if I get confused, you know. Anyway, the thing about air quality standards is that there are different levels of legal status, and this is really quite important because the majority of people outside the legal profession and outside governments are really rather more concerned about improving public health, whereas when you get into the difficult problem of formulating laws and so forth, then people tend to think a little bit differently, and there are different levels of standard, as we'll see. In the EU directives that governments have to comply with, there are what we call hard law limit values, and these are absolute standards that have to be complied with. Member states in the EU must meet them everywhere. There are other levels called target values, which we won't really need to go into now, and they're slightly softer. The language in the laws are that you should do your best to meet them, essentially. You don't necessarily have to meet them everywhere, but you should try pretty hard to do it. And then we have the World Health Organization guidelines. Now, these are set without any regard to how feasible they may be to achieve, or how difficult they may be, or how technologically costly they may be. They're set purely on health terms, and they're set at a level at which you would expect to see not much of a public health effect from air pollution at that particular level. So you can see there's quite a difference in these standards, and that's really quite important. The European Commission has always said that it will take as a starting point for its legislation the World Health Organization guidelines. And from then on, all hell can break loose, because member states start negotiating, and all kinds of interests from industry and from NGOs come into play, and all sorts of things can happen. But the starting point of European legislation is always the World Health Organization guideline. Which is, I hope, what's on there.
It's not the right hand.
The
Point at the laptop.
The white one.
Yeah, the white one. Point at me.
Okay, I'll press the button. It's always the first speaker that solves the problems for everybody else. Okay. Well, that's okay. Okay, seems to work. Okay. Well, the first bullet point on there is something I've already said, and then once the Commission has made a proposal, then the Member States meet in the Council of Ministers, the European Parliament meets, and there's a three-way negotiation that can take up to, well, many years in some cases to reach agreement. And usually those WHO guidelines get changed in the negotiating process as Member States consider that some guidelines are too difficult to meet and so on. Where that didn't happen was in the case of NO2, and at the present time the limit value, the hard law standard that Member States have to meet is the same number as the WHO guideline. And that actually is really quite a tough guideline to meet. And that's why the large majority of Member States are now in non-compliance with the EU directive and are facing fines. And you've already seen the problem outlined in the earlier slides already this evening. The pollutants that are covered in the Air Quality Directive are listed up there. I don't propose to go through them or tell you all the numbers that you have to meet and so on. That wouldn't be appropriate. The important point to make, though, is that the European Commission in December of last year produced an air quality package, a clean air programme for Europe, which proposed a lot of new legislation and revisions to existing legislation. And one thing it didn't do was to propose to revise this directive to change the limits and the standards that are already in place. And the reasons for that we don't need to go into. They were complex and difficult, but the consensus within the Commission when they produced this package was that they, rather than try and impose even more burdens on Member States, that they would, at the moment, just pause and try and achieve compliance with the existing standards, because as I've already said, a large number of Member States aren't complying now, so there didn't seem to be a lot of advantage in pushing even harder. So the position is that the directive will potentially be revised in a few years' time, but in the meantime, the Commission and Member States will have to work together to achieve compliance with the existing standards. So, there we are. I just wanted to say a little bit about particles. I gather you've already had a lot of talks up until now on health effects of air pollutants, but in case you haven't, or if some of you weren't there, it's quite important to realise how small these things are. This is a human hair. PM10 that you'll have heard about is that sort of size. PM2.5 is even smaller. and so-called nanoparticles, the ultrafines that are emitted directly by vehicles that are even smaller still, almost at atomic molecular dimensions, really very small indeed. And that's what a blown-up microscope, electron microscope slide of a particle looks like. This is a particle from diesel exhaust, and these are bigger dust particles. But the current thinking is that the burden from particle pollution in the EU in 2010 was valued at somewhere between 300 and 900 million euros per year, with premature deaths of the order of 400,000. So really quite a big public health problem. And the evidence for that is extensive, and we don't have time to go into any of that. But one key slide is this study from the US, which, whoops, okay. Press escape by mistake. Right, okay. Yeah. I meant to press the pointer. Anyway, this is a slide that relates the life expectancy here against PM 2.5 concentration here. It's a study in the United States, but there's a very large sample. You can see quite a clear decrease in life expectancy as pollution levels measured as PM 2.5 go up. Now, we're getting on to the more interesting bit in terms of what we might be able to do about it. And the important point to make here is that the particles that you measure in the atmosphere are complex, different from the gaseous pollutants. A molecule of NO2 is the same here as it is on the moon. Particles vary very much in time and in space, depending where you are, what the sources are. They can be very complicated entities indeed, with a lot of different chemicals on the surface of the particles and inside. And that makes controlling them difficult and challenging. And this slide I didn't do that. This slide shows a very broad makeup of the chemistry of particles. This piece of the pie is the primary emission, the soot, if you like, that comes out of diesel vehicles or smoke from chimneys, wood burning, and so on. These fractions, which amount almost to half, this is data from the UK, but it's very similar in most places in Northern Europe. This part of the mix is formed from chemical reactions in the atmosphere, from pollutants that are emitted potentially many hundreds of kilometers upstream, because the reactions that form these parts of the particle mix can take many hours or even days to take place. So the particles that you measure in Antwerp or in London, a large part of them could have arisen from emissions somewhere else. And then we have other things like mineral dust, sea salt, and water, and so on. But the important point to make here is that particles arise from a range of sources over very large geographical areas, potentially. And, oh dear, it's locked again. Okay, we can skip over that actually. Okay, yeah, this is the important slide. This shows a typical cross-section. This is actually a cross-section of particles across London. Particle concentration, the total looks like this. And this part are those chemically formed particles that I talked about just now, and have arisen from emissions maybe in the rest of the UK, maybe in the rest of Europe. But they form a kind of baseline on which the local emissions are superimposed, and so these peaks are where there are busy roads and so forth. So the message from this is that even if you control a large part of your local pollution, you'll only have a limited amount of reduction that you can make in the total particle burden. And that's actually quite important. To reduce this part of the particle concentration, then you need international action. And that's where the Commission's proposals to revise what's called the National Emission Ceilings Directive is important, because that actually commits member states to reducing the pollutants that form these particles. So what's needed to reduce total PM 2.5, total particle burden, is a mixture of local action, national action, local action in cities, and international action across Europe. So that's one take-home message, I think, that I wanted to get across. Well, you might ask, well, okay, they're coming from somewhere else, so who's to blame? Who do we look to? Now, within, there's a Geneva Convention on air pollution, transboundary air pollution, internationally transported air pollution, and a lot of the science that underpins that addresses this particular point. And it looks at the way pollutants move from one country to another. And you can find all this stuff on the web, there's no secret about any of this. And what I've done is look at the contributions to PM 2.5 in Belgium from the model run in Norway for the Convention in Geneva. This is the totality of PM 2.5. The proportion that the model thinks is coming from Belgium is 20%. This piece comes from France, this from Germany, this from the UK, this from the Netherlands, this from the North Sea, from ships. And then this is called others, and so there's a whole range of other countries in here. But you can see the kind of conclusion that you can get from this analytical modelling. And these are the sort of things that the Commission's Emission Ceilings Directive and the Convention in Geneva will look to address to see how emission reductions in these countries and in Belgium itself will affect this overall concentration. I just wanted to move towards the end of the talk and go back to this difference between air quality standards in terms of limit values, the hard law, and World Health Organization guidelines, and talk a little bit about NO2, where the problem really is. And this slide shows the percentage of the urban population in the EU which is exceeding WHO guidelines. Now, if you remember, the WHO guidelines are really quite stringent. They are set purely on health terms, no consideration of how difficult they may be to achieve economically or in terms of cost or whatever, technology. And so for ozone, pretty much the whole population is exceeding WHO guidelines. PM10, anywhere between 70 and 90%, depending on which year you look at. This graph, by the way, if you can't see it, that goes from 2002 to 2011, from 0 to 100%. Dark blue is sulfur dioxide, and that's really one of the big success stories in Europe. Emissions of sulfur dioxide have fallen dramatically in the last 30 years or so. Reductions of maybe 90% over that period. Big reductions in sulfur dioxide. NO2 has come down, but I'm going to see more of this in a little while. It's really not come down as fast as we thought. There was still of the order of 10% of the urban population exceeding the WHO guideline, which was actually the same as this is now the similar graph for the EU limit values. It's the hard law. And you can see the difference already. Far smaller percentage of the population comply with the EU standards, because the standards have been negotiated at a level that are less stringent, less tough than the World Health Organization guidelines. So far fewer people are exposed to those levels. But NO2 is the same, because the two numbers are the same. And there are reductions in the others. Now, NO2, as you've already seen in Antwerp and locally, is a significant problem. The issue, you won't be able to read these, but each of these graphs is a trend plot from 1995 to 2010 or 2011 from each, well, from 12 member states in the EU. And the main point to make is, apart from one or two exceptions like Greece here and Italy, the trends are pretty much flat. There's been no real big decrease in NO2 over the last 20 years or so in Europe. And that's not what we expected. We thought the controls on motor vehicles, which is the prime source of NO2 in urban areas, we thought those regulations would work and that emissions would improve and concentrations would come down, but they didn't. And the reason for that is shown on this side. Now, the thing to concentrate on are these two graphs here. And what these show are the red and blue. This is petrol cars and this is diesel cars. And the bottom axis here shows different levels of Euro standard, the different increasingly stringent Euro standards in the regulations from pre-Euro 1, Euro 0 through to Euro 6. The red and blue lines show the numbers that people thought should be the emissions, the numbers that are used in emission inventories, in calculations of national total emissions and so on. That's essentially what we thought would happen. And the green lines show measurements of emissions from these cars in the real world, actually in the UK, mostly in London, but in real driving. And you can see for petrol cars, the real emissions have actually come down pretty much as expected, and the reason for that is that catalytic converters on petrol cars actually work, and they work very well. There were some initial teething troubles when they didn't work as well as we thought they might, but now they work very well indeed and really remove virtually all the NOx emissions from petrol cars. For diesel cars, the story is totally different. There's been no real improvement in the last 20 years of regulation of diesel car NOx emissions. And that's really quite a staggering finding. And that's one of the main reasons for that previous slide showing virtually no improvement in NO2 concentrations in Europe. Two reasons. One is that the regulations themselves have failed, as I'll show in a minute, and the other reason, of course, is that most member states in the EU have been encouraging the use of diesel cars, and the percentage of diesel cars in the population, certainly in the UK and in most other countries in Europe, has increased steadily over the last 20 years. So we've got two factors: a failure in regulation and an increase in diesel cars in the fleet, on the street, which has led to the fact that we just haven't seen any improvement in NO2 concentrations. Now, the reason for that, and this is a slightly complicated slide, but I won't go into too much detail, but essentially what it shows is what's called an engine map. This is the sort of operating conditions of a car in real use. At this axis we have the power, torque in English, power that you generate, and across the x-axis here are the engine revolutions per minute. And the test cycle that manufacturers have to drive a car over to meet the regulated standard really only samples this part of the operational mode of the car. Real world driving covers pretty much the whole of this engine map. The test cycle is really not anywhere near representative of real world driving conditions. And you can see that it really only samples a very small part of the real operating conditions of cars in use. And Jan Kortfried from the Commission will talk a little bit more about that and the steps that are being taken to address this problem in a short while. So those are two messages that I wanted to leave with you. One on the NO2 problem. You know, you've got a big problem with we, everyone in the EU has a problem with diesel cars. Now, I'm not suggesting that you should take action on that, but that's certainly something you need to think about when you're thinking about improving air quality in urban areas in Belgium. And secondly, the message on PM 2.5, I guess, is that you can certainly take local action to reduce PM 2.5 levels, and it'll be very beneficial, and it'll be a good thing to do. But don't get too ambitious, don't get too optimistic. this background from everywhere else in Europe will mean that you won't reduce everything on your own. There'll need to be international cooperation. And I guess those are the two main messages I wanted to leave with you. Thank you.